Now we are moving like step number 5, using message as a state. Okay, since conversation are dynamic, so we need to store all the previous message as a part of the state. Okay, if we just overwrite the message with each new response, we would lose the conversation history. Okay, if we overwrite the message, okay, with each new response, then it will lose conversation history. So solve this, we use reducer. Okay, so here I'm going to use message. Okay, so since the conversation are dynamic, so we need to store all the previous state as a part of message. Okay, so if if we just override the message with each new response, we would lose the conversation history. Okay, so here you can see we are going to like use this one state. Yeah, using message as a state, using message as a state. Okay, here you can see this one. uh, so we have problem here. So resolve this, we can use reducer. Okay, a reducer define how new value update the state. Okay, so with the help of reducer, it will update a new value of the state. Okay, so these are the parameters. By default, the new value override the old one. Okay, so if you have new value, then it will override with the old one. Okay, with reducer we can customize the update process. Okay, for message we don't want to override, we want to append each new message to existing list. Okay, so LangGraph provide a built-in reducer called add message. Okay, so this is the built-in reducer that is called a add message, and it will use to update the state. Okay, this ensure new message are always added to the list of old message, and the entire conversation history is preserved. So here I already have code in this. I need to copy it. Okay, so here from langchain.graph.message import add message. Okay, this is the reducer to update the states. Okay, from typing import annotation for adding it will show you like labels for class. This is the class, and here we are going to pass type dict and message annotation list any message add message. Okay, this will show you like labels like that is human or AI based message. And after this I need to copy this and paste it here. Reducer with add message. Okay, so here this is the initial message, and initial message dot append human message. Okay, this is for AI, please tell me how can I help you, LLM model. And this is for human, initial message dot append human message content. I want to learn coding. Okay, name equals to Nidhi. So here I want to run this. Okay, so this is the AI message and response, and this is the human message. And in content I want to learn coding. Okay, and here you can see please tell me how can I help you. This is the AI message. Okay, and after this I need to write this here. Okay, so which programming AI, again again asking you which programming language you want to learn. Okay, AI asking you which programming language you want to learn. Okay, so after this we want to add here add reducer add message. So here add message, initial message and AI message. Okay, so these are the AI message and these are the initial message. Okay, Then it will saying, please tell me how can I help you. And human message, I want to learn coding. AI again asking you which programming language you want to learn. Okay, so uh, this is by reducer. Add message is to append instead of override. Okay, add message is to append instead of override. Okay, so here we are going to append this one, which programming language you want to learn, this one. So now chatbot node functionality. Okay, so we already knew about a node and LangGraph. Okay, so example of nodes: one node can represent the LLM generating a response, another node can represent a tool being called, and another node can represent the state update. Okay, so we have different nodes, and these nodes work on different tasks on different tasks. So by combining nodes, we can build a complex conversation agent. Okay, node is just a function. Okay, node are connected using edges. We define how the flow move from one node to another node. Okay, so we start LLM nodes, tool node, and end. Okay, so this means start conversation, LLM process the query. Start conversation, LLM process the query. If needed, LLM call tools. Okay, otherwise it will return the response in final step. Okay, so here in step 7, you can see. Okay, so here I'm going to define chat node functionality. So this is the function LLM tool. Here this is the step and return message LLM with tool dot invoke state message. Okay, that it will invoke message. And after this, okay, so after this I'm going to import ipython.display import image and display. Okay, that we can display this graph. Okay, so builder equals to state graph equals to state. Okay, we already knew about it. Okay, so builder dot add node. Here we are going to add nodes. So here this is the LLM tool, and builder dot edges. So this is for edges start, an LLM tool, and this is for also edges LLM tool, and this is for end, and this is for start. Okay, so here graph equals to builder dot compile and display the graph. Okay. So graph will be in Maramat PNG file. Okay, start LLM tool or end. This one. Start LLM tool or end. Okay. If you want to call according to your query, LLM decide which tool I can call or not. Okay. And after this, now our third invocation. Here you can see an invocation message equals to graph dot invoke message. What is 2 plus 2? Okay, for message in message. Okay, here I'm going to pass message and message dot pretty print. Okay, that's it will give you result in pretty form. Okay, what is 2 plus tool call? A tool vision add. Okay, so here argument equals to a and v. We already have this one, this tool, this one, this one. So this is used to add function for calling tool. After this, now I am going to write this tool equals to add. So here you can see tool equals to add. We can also check this one. Okay, and after that, after this, we move on conditional edges. Sometimes the next step depend on the result. Okay, if the LLM produce a tool call, go to the tool node. If the LLM does not call a tool, go directly to end. Okay, If LLM produce a tool call, go to the tool node. Otherwise, if not call a tool, go directly and end. Okay, this is handled by conditional age. This is which let the graph decide dynamically which path to take. So here I'm gonna copy it. Here from LangChain dot pre-build, we are going to import tool node and tool conditions. Okay. Here builder request to state graph state. Okay. So here this is the for initialization of graph, and here these are the nodes, add nodes, builder dot add nodes, and here you can see we are going to add edges. Okay. Builder dot edges. This is for star and this is for conditional edges, and this is tool call. If the latest message from assistant is tool call, condition route to tool call. Okay, so tool call this okay, and this is the tool condition I'm going to pass here, and builder dot is tool and end. So here we are going to end it. Now I'm going to run, and after this I need to compile this. After this graph.builder and compile. Now I want to display its image, this one. With the help of this line we can display the images of the graph. Here you can see this is our graph. Start LLM tool and end. And after this invocation, okay, so here you can see what is 2 plus 2, a message and in pretty form. Okay, so this is the response. Now I'm going to ask the question. The question is what is machine learning? A message in messages. So here I got error. Okay, so here I need to check this. Okay, so this will give you a response. What is 2 plus 2? And second question is what is machine learning? And machine learning is subset of artificial intelligence. Okay, so these are the answer. Okay, applications of machine learning. Okay, guys, I think you got this lecture. Chain using LangChain. Okay, so here we did things using chat message as a graph state, using chat model in graph nodes, binding tool to our LLM in chat model, executing tool LLM tool call inside the graph node. Okay, so here you can see these are the APIs I was importing from .env file, and this is step for chat message as a graph state. Okay, so these are the message like AI message, human message. Okay, and here you can see this is the chat model. So what is the chat model? Like if we have a sequence of messages, then we can feed them into a chat model. Okay, so we have different kind of models. By using OpenAI API and Grok and Anthropic, so we have different model. They understand like a chat model are different from plain text. Um, plain text completion model, because they are designed for multi-turn conversation, and they understand who is speaking, like whom, human or AI. Okay, so this is for model. And here we are going to like feed message to this model. Okay, here you can see LLM equals to this model and LLM dot invoke message. Okay, and this is the response via LLM, and this is the tool like external function like API, local function or database. So here this is the tool. We can also create by our own. So this is for calculator, and this is binding tool with the LLM. Just having tool is not enough, we must bind them to the LLM. Okay, building means connecting the tool to the model. We are going to connect tool to the model, so the model know these tools exist and call them when needed. Okay, so when tool are bound, LLM can detect if user query require a tool. Like if user query like from weather API, then it will detect that we need to call this weather API tool. Okay, and call the correct tool automatically, and use the tools response to the answer the user. Okay, using message as a state. Since conversation are dynamic, we need to store all previous message as a part of the state. Okay, if we just override the message, each new response would be lose with each new message. If we override the message with the each new message, it would lose the conversation history. So we will reduce it by reducer. Okay, so we can add message. Like here reducer define how new value update the state. Okay, so it will use to update the state. Here by using add message, LangGraph provide a built-in reducer called add message. This ensures new messages are always added to the list of old message. New messages are always added to the list of old message, and the entire conversation history is preserved. And reducer with add message, and here we can see chatbot node functionality. Okay, so here we are going to use nodes. So here this is the flow: start LLM nodes, tool node, and end. Start conversation here, and LLM responds the query, and if need, then we can then it will call a tool. Otherwise it will end and return the response. Okay, so here you can see chatbot node functionality, and here these are the nodes, and these are the edges, and here this is for graph. Here we can see this is the graph in marmot png. Okay, so this is our invocation, and here you can see conditional edges, like if the LLM provide a tool call, go to the tool node. Otherwise it will go directly, and it will end. Okay, so here this is for this one. So here this is for initialization of graph. These are the nodes, and these are the edges, and this is the condition edges in which tool we want to go. Okay, so after this we are going to uh, we are going to compile the graph here, and we are going to display the graph. Okay, now these are the questions we will ask from model, or if you want to write any question you can change, then you will ask the question. Then this is the response. Okay, summary you can see here: message, maintain the conversation state. Okay, so in message, maintain the conversation state, and chat model generate the intelligence response. Chat model generate the intelligent response, and tool extend the model ability, and reducer ensure the history is preserved. Okay, graph node plus edit define the flow of execution.